Okay, for today's lesson, we're going to look at inequalities involving two triangles. So this is section 5-5. All students will be able to apply the SAS inequality theorem, and all students will be able to apply the SSS inequality theorem. The basic idea behind these theorems is, imagine for a moment that we had a pair of sticks, and we join those sticks at point B. Notice that when we take these pair of sticks and imagine that point B is a hinge, when I open this angle larger, that we're going to make this side from A to C, we're going to make that longer. For example, if I opened it up, let's say this is A, B, and C, and I made this angle bigger, this third side is going to be longer. Similarly, if I took these pair of sticks and moved this angle in smaller, that the length of AC is going to end up being smaller as well. That's the idea behind these two theorems, and now you might understand why sometimes they have the nickname the hinge theorems. The first of these theorems is theorem 5.13, the SAS inequality theorem. Homework theorem 6-5, which states that two sides of a triangle are congruent to two sides of another triangle. If the included angle in the first triangle has a greater measure than the included angle in the second triangle, then the third side where was I? The third side of the first triangle is longer than the third side of the second triangle. All right, that was a long one. Let me draw a picture to show what's going on here. Let's say that we have triangle ABC such that we'll put one tick mark on AB, one tick mark on AC, and we'll call angle BAC angle 1. Similarly, let's have triangle PQR such that PQ is congruent to AB, PR is congruent to AC, and we'll call angle QPR angle 2. What we're saying is, if segment AB is congruent to segment PQ, segment AC is congruent to segment PR, and the measure of angle 1 is greater than the measure of angle 2, then the measure of BC is greater than the measure of QR. It's like opening up the hinge, so to speak. Similarly, Theorem 5.4 is called the SSS inequality theorem. Homework theorem 6-6. If two sides of a triangle are congruent to two sides of another triangle, and the third side in one triangle is longer than the third side in the other, then the angle between the pair of not really congruent sides, the pair of given sides, we'll say, in the first triangle is greater than the corresponding angle in the second triangle. Whew. All right. So, for example, what we're saying is that, let's say I have triangle ABC. Let's put one tick mark on AB, 2 on AC, call this angle 1. And we have triangle PQR. Let's put one tick mark here, 2 tick marks here, and call this angle 2. What we're saying is, if segment AB is congruent to segment PQ, segment AC is congruent to segment PR, and the measure of BC is greater than the measure of QR, then the measure of angle 1 is greater than the measure of angle 2. Let's take a look at a couple of examples on how we can use these two theorems. Example 1. Let's say that you're given that segment RS is congruent to segment RT, that the measure of angle 1 is greater than the measure of angle 2. The question might be, what can you deduce from this picture? So, angles 1 and 2, segments R, points R, S, V, and T. Well, we're given that RS is congruent to RT. We're also given that segment RV is congruent to itself. Well, we're not given that. We can conclude that by the reflexive property. But we also know that angle 1 is greater than the measure of angle 2. So I'm putting 2 tick marks on angle 1, 2 arcs on angle 1, and 1 arc on angle 2. Now, hopefully you can see that because of that, we can conclude that the measure of SV is greater than the measure of VT. The reason for that? The SAS inequality theorem. Notice that when we talk about the SAS inequality theorem, we're working with two sides and we're given information about the included angle. Unlike the SSS inequality theorem, where we have our two sides and we're given information about the third side. Let's do one more. Example 2. Given that segment BC is congruent to segment DC and the measure of AB is greater than the measure of AD, we would like to prove that the measure of angle 1 is greater than the measure of angle 2 in this picture. A, B, C, D, angle 1 and angle 2. So before I start writing out my statements and reasons, let me mark up the picture. We're given that BC is congruent to DC, that AB is greater than AD. So I'm going to put 2 dots right here, and I'm going to put 1 dot right there, kind of to show that AB is greater than AD. I also recognize that segment AC is congruent to itself. So now it makes sense to me that by the side-side-side inequality theorem that I can show that the measure of angle 1 is going to be greater than the measure of angle 2. So let me write that out. Yeah, segment BC is congruent to segment DC, that the measure of AB is greater than the measure of AD. That was given. We also can say that segment AC is congruent to itself by the reflexive property. Now, I have that information about 2 sides. BC is congruent to DC, and AC is congruent to itself. We know in the third side that the measure of AB is greater than the measure of AD. Therefore, I'm going to say that the measure of angle 1 is greater than the measure of angle 2 by the side-side-side inequality theorem. Now, that's the lesson, but I have one more task for you. After you do the classwork problems that I gave you, the problems on that classwork worksheet that are going to be due tomorrow, I have one more task for you. What I want you to do is I want you to go to the Khan Academy website. The Khan Academy website is khanacademy.org, as you can see up here. And what I want you to do is I want you to create a profile. This is going to be my first time doing this in a class, so we might have some issues as we go along through this, but that's okay, we'll figure it out. What I want you to do is from the Khan Academy page, I want you to create an account. So you're going to sign up. And you could either sign up using a Google account if you have one. I've never done with the Facebook, so I'm not quite sure how that's going to work. Or I guess maybe there's another way of doing it through this. I'm not quite sure. But what I want to be able to do is whatever you're logging in through, I should be able to tell who it is. So make sure that your full name is part of this some way, somehow. After you've done that and you're logged in, what I want you to do is I want you to go to the coach page. And, oh, actually, let's follow the directions in here and what they say to do. They say, let me go back up. Manage students. This is for me. This is my page. What I want you to do is you're going to select me as a coach for Khan Academy. So what you're going to do is you're going to visit your profile by clicking your name at the top of the page. For example, your name will be right here. Then you're going to click on the Coaches tab, people, right down there. And then you're going to enter My Coaching ID where it says Add a Coach. So right in there, you're going to put mrconlon314@gmail.com. Then what you're going to do is you're going to go up to some of these practice problems. And what I want you to do is I want you to mess around a little bit. You'll see that you have some different things to try here. Mess around with it for a little bit. I'm not worried about exactly which ones you're going to do right now. I might assign some at some point. But for now, just mess around with that, okay? And if you have any questions, we can figure it out tomorrow. Otherwise, good luck, have fun, and I'll see you tomorrow. Thanks.